blockchain is a distributed database that maintains a continuously growing list of records, called blocks, which are linked and secured using cryptography. Each block contains a timestamp and a link to a previous block. By design, blockchains are inherently resistant to modification of data. Blockchain technology has a number of features that make it attractive for a variety of applications, including security. Blockchain is a secure technology because it is decentralized and tamper-proof. The data in a blockchain is stored across a network of computers, so it is not vulnerable to attack by a single entity. Transparency. Blockchain is a transparent technology because all transactions are recorded on the blockchain and are visible to everyone on the network. This makes it difficult to commit fraud or corruption. Immutability. Blockchain is an immutable technology because once data is added to the blockchain, it cannot be changed. This makes it a reliable way to store records. Efficiency. Blockchain can be used to automate transactions and reduce the need for intermediaries, which can save time and money. Some of the potential applications of blockchain technology include financial transactions. Blockchain can be used to record financial transactions, such as payments and investments. This can make it more efficient and secure to transfer money. Supply chain management. Blockchain can be used to track the movement of goods and materials through a supply chain. This can improve efficiency and transparency. Healthcare. Blockchain can be used to store medical records and track the movement of drugs. This can improve patient safety and reduce fraud. Voting. Blockchain can be used to create a secure and transparent voting system. This can help to prevent voter fraud. Intellectual property. Blockchain can be used to register and track intellectual property, such as patents and copyrights. This can help to protect intellectual property rights. Blockchain technology is still in its early stages of development, but it has the potential to revolutionize a variety of industries. As the technology matures, we can expect to see even more innovative and widespread applications of blockchain. Suppose you are transferring money to your family or friends from your bank account. You would log into online banking and transfer the amount to the other person using their account number. When the transaction is done, your bank updates the transaction records. It seems simple enough, right? There is a potential issue which most of us neglect. These types of transactions can be tampered with very quickly. People who are familiar with this truth are often wary of using these types of transactions, hence the evolution of third-party payment applications in recent years. But this vulnerability is essentially why blockchain technology was created. Technologically, blockchain is a digital ledger that is gaining a lot of attention and traction recently. But why has it become so popular? Well, let's dig into it to fathom the whole concept. Record keeping of data and transactions are a crucial part of the business. Often, this information is handled in-house or passed through a third party like brokers, bankers, or lawyers, increasing time, cost, or both on the business. Fortunately, blockchain avoids this long process and facilitates the faster movement of the transaction, thereby saving both time and money. Most people assume blockchain and Bitcoin can be used interchangeably, but in reality, that's not the case. Blockchain is the technology capable of supporting various applications related to multiple industries like finance, supply chain, manufacturing, etc., but Bitcoin is a currency that relies on blockchain technology to be secure. There are different types of blockchains. They are as follows. Private blockchain networks. Private blockchains operate on closed networks, and tend to work well for private businesses and organizations. Companies can use private blockchains to customize their accessibility and authorization preferences, parameters to the network, and other important security options. Only one authority manages a private blockchain network. Public blockchain networks. Bitcoin and other cryptocurrencies originated from public blockchains, which also played a role in popularizing distributed ledger technology, DLT. Public blockchains also help to eliminate certain challenges and issues, such as security flaws and centralization. With DLT, data is distributed across a peer-to-peer network, rather than being stored in a single location. A consensus algorithm is used for verifying information authenticity, proof of stake, POS, and proof of work, POW, are two frequently used consensus methods. Permissioned blockchain networks. Also sometimes known as hybrid blockchains, permissioned blockchain networks are private blockchains that allow special access for authorized individuals. Organizations typically set up these types of blockchains to get the best of both worlds, and it enables better structure when assigning who can participate in the network and in what transactions. Consortium blockchains. Similar to permissioned blockchains, consortium blockchains have both public and private components, except multiple organizations will manage a single consortium blockchain network. Although these types of blockchains can initially be more complex to set up, once they are running, they can offer better security. Additionally, consortium blockchains are optimal for collaboration with multiple organizations. Hybrid blockchains. Hybrid blockchains are the combination of both public and private blockchains. In a hybrid blockchain, some parts of the blockchain are public and transparent, while others are private and accessible only to authorized and specific participants. This makes hybrid blockchains ideal for use in those cases where a balance is required between transparency and privacy. For example, in supply chain management, multiple parties can access certain information, but sensitive data can be kept private. Side chains. Side chains are different blockchains that run parallel to the main blockchain, allowing for additional functionality and scalability. Side chains enable developers to experiment with new features and applications without affecting the main blockchain's integrity. For example, side chains can be used for creating decentralized applications and to implement specific consensus mechanisms. Side chains can also be used to handle transactions of the main blockchain to reduce congestion and increase scalability. A blockchain is a distributed, immutable, and decentralized ledger at its core that consists of a chain of blocks, and each block contains a set of data. The blocks are linked together using cryptographic techniques and form a chronological chain of information. The structure of a blockchain is designed to ensure the security of data through its consensus mechanism, which has a network of nodes that agree on the validity of transactions before adding them to the blockchain. Blocks. A block in a blockchain is a combination of three main components. 1. The header contains metadata such as a timestamp, which has a random number used in the mining process, and the previous block's hash. 2. The data section contains the main and actual information like transactions and smart contracts, which are stored in the block. 3. Lastly, the hash is a unique cryptographic value that works as a representative of the entire block, which is used for verification purposes. Block time. Block time refers to the time taken to generate a new block in a blockchain. Different blockchains have different block times, which can vary from a few seconds to minutes or maybe in hours too. Shorter block times can give faster transaction confirmations, but the result has higher chances of conflicts, but the longer block times may increase the timing for transaction confirmations but reduce the chances of conflicts. Hard forks. A hard fork in a blockchain refers to a permanent divergence in the blockchain's history that results in two separate chains. It can happen due to a fundamental change in the protocol of a blockchain and all nodes do not agree on the update. Hard forks can create new cryptocurrencies or the splitting of existing ones, and it requires consensus among the network participants to resolve. Decentralization. Decentralization is the key feature of blockchain technology. In a decentralized blockchain, there is no single central authority that can control the network. In decentralization, the decision-making power is distributed among a network of nodes that collectively validate and agree on the transactions to be added to the blockchain. This decentralized nature of blockchain technology helps to promote transparency, trust, and security. It also reduces the risk to rely on a single point of failure and minimizes the risks of data manipulation. Finality. Finality refers to the irreversible confirmation of transactions in a blockchain. If and when a transaction is added to a block and the block is confirmed by the network, it becomes immutable and cannot be reversed. This feature ensures the integrity of the data and prevents double spending, providing a high level of security and trust in blockchain types and sustainability. Openness. Openness in blockchain technology makes the blockchain accessible to anyone who intends to participate in the network. This implies that it is open for all and anyone can join the network, validate transactions, and can add new blocks to the blockchain, so long as they know the consensus rules. Openness promotes inclusivity, transparency, and innovation, as it allows for participation from various stakeholders. In recent years, you may have noticed many businesses around the world integrating blockchain technology. But how exactly does blockchain technology work? Is this a significant change or a simple addition? The advancements of blockchain are still young and have the potential to be revolutionary in the future, so, let's begin demystifying this technology. Blockchain is a combination of three leading technologies. Cryptographic keys. A peer-to-peer network containing a shared ledger. A means of computing, to store the transactions and records of the network. Cryptography keys consist of two keys, private key and public key. These keys help in performing successful transactions between two parties. Each individual has these two keys, which they use to produce a secure digital identity reference. This secured identity is the most important aspect of blockchain technology. In the world of cryptocurrency, this identity is referred to as digital signature and is used for authorizing and controlling transactions. The digital signature is merged with the peer-to-peer network. A large number of individuals who act as authorities use the digital signature in order to reach a consensus on transactions, among other issues. When they authorize a deal, it is certified by a mathematical verification, which results in a successful secured transaction between the two network-connected parties. So to sum it up, blockchain users employ cryptography keys to perform different types of digital interactions over the peer-to-peer network. Here is a specific example of how blockchain is being used in the supply chain industry. Walmart is using blockchain to track the movement of mangoes from farms in Mexico to stores in the United States. This helps to ensure that the mangoes are fresh and safe to eat, and it also helps to reduce food waste. Another example is the use of blockchain in the healthcare industry. MediLedger is a blockchain platform that is being used to track the movement of prescription drugs. This helps to prevent counterfeit drugs from entering the supply chain, and it also helps to ensure that patients get the medications they need. These are just a few examples of how blockchain is being used today. As the technology matures, we can expect to see even more innovative and widespread applications of blockchain. Here is how blockchain works in each of the examples you mentioned. Financial transactions. In the case of Bitcoin, each transaction is recorded in a block. The block is then added to the blockchain, which is a public ledger that is distributed across a network of computers. This makes it very difficult to tamper with the blockchain, as any changes would be immediately visible to everyone on the network. In the case of Bitcoin, each transaction is verified by a network of miners. Miners are computers that compete to solve complex mathematical problems. The first miner to solve the problem is rewarded with a certain amount of Bitcoin. This process helps to ensure that the blockchain is secure and tamper-proof. Supply chain management. In the case of the Walmart mango supply chain, each mango is assigned a unique identifier that is stored on the blockchain. This identifier is then used to track the mango as it moves through the supply chain. This information can be used to ensure that the mangoes are fresh and safe to eat, and it can also be used to reduce food waste. In the case of the Walmart mango supply chain, the data on the blockchain is updated by a variety of stakeholders, including farmers, shippers, and retailers. This ensures that the information on the blockchain is accurate and up-to-date. Healthcare. In the case of MediLedger, each prescription drug is assigned a unique identifier that is stored on the blockchain. This identifier is then used to track the drug as it moves through the supply chain. This information can be used to prevent counterfeit drugs from entering the supply chain, and it can also be used to ensure that patients get the medications they need. In the case of MediLedger, the data on the blockchain is encrypted and stored in a secure manner. This helps to protect the privacy of patient information. These are just a few examples of how blockchain works. As the technology matures, we can expect to see even more innovative and widespread applications of blockchain. Security. Blockchain is a secure technology because it is decentralized and tamper-proof. The data in a blockchain is stored across a network of computers, so it is not vulnerable to attack by a single entity. Transparency. Blockchain is a transparent technology because all transactions are recorded on the blockchain and are visible to everyone on the network. This makes it difficult to commit fraud or corruption. Immutability. Blockchain is an immutable technology because once data is added to the blockchain, it cannot be changed. This makes it a reliable way to store records. Efficiency. Blockchain can be used to automate transactions and reduce the need for intermediaries, which can save time and money. Cost effectiveness. Blockchain can help to reduce costs by eliminating the need for intermediaries and by streamlining processes. Scalability. Blockchain is scalable, meaning that it can be used to handle a large number of transactions. Sustainability. Blockchain can help to reduce energy consumption and environmental impact by eliminating the need for paper records and by reducing the need for intermediaries. These are just some of the benefits of blockchain technology. As the technology matures, we can expect to see even more benefits emerge. Blockchain is a rapidly growing technology with a wide range of potential applications. As a result, there are many career opportunities in blockchain, both in India and abroad. Some of the most common blockchain career opportunities include blockchain developer. Blockchain developers are responsible for designing, developing, and testing blockchain applications. Blockchain architect. Blockchain architects are responsible for designing and implementing blockchain solutions for businesses and organizations. Blockchain security engineer. Blockchain security engineers are responsible for securing blockchain applications and networks. Blockchain consultant. Blockchain consultants advise businesses and organizations on how to use blockchain technology. Blockchain researcher. Blockchain researchers are responsible for developing new blockchain technologies and applications. The demand for blockchain developers is growing rapidly, and the average salary for a blockchain developer in India is 8 rupees lakh per annum. The highest paying companies for blockchain developers in India include IBM, Visa, Microsoft, and Deloitte Consulting LLP. Learn about blockchain technology. There are many resources available online and in libraries. Develop your coding skills. Blockchain developers need to be proficient in coding languages such as Python, Java, and Solidity. Network with other blockchain professionals. Attend blockchain meetups and conferences. Get involved in open source blockchain projects. This is a great way to learn about blockchain technology and to build your portfolio. The blockchain industry is growing rapidly, and there are many opportunities for skilled blockchain professionals. If you are interested in a career in blockchain, I encourage you to learn more about the technology and to develop your skills. Here are some additional tips for getting a career in blockchain. Be proactive. Don't wait for opportunities to come to you. Reach out to companies and organizations that are using blockchain technology and let them know that you are interested in working with them. Be patient. It takes time to develop the skills and experience you need to get a good job in blockchain. Don't get discouraged if you don't get your dream job right away. Keep learning and growing, and eventually you will find the right opportunity.